All right, Algebra 2 boys and girls, we're moving on from the rational expressions and stepping into right triangle trigonometry. Trigonometry is the study of triangles. So we'll start with right triangles. Right triangles, triangle with an angle of 90 degrees. Okay. With a right triangle, opposite of the right angle is something called the hypotenuse. And then these two sides that are not the hypotenuse are called the legs. All right, so we have a leg 1, leg 2, and then opposite of the right angle is called the hypotenuse. All right. Now the first thing we need to know about these triangles before we get into the little trig functions is that if I have a right triangle, say this is 45 degrees, okay, these two angles here have to add up to 90 degrees. So say they're both 45 degrees, and say this is a length of 1 foot or 1 mile, whatever you want to be. Using the Pythagorean theorem, which I'm assuming you know the Pythagorean theorem, a squared plus b squared equals c squared. That's a leg squared plus the other leg squared equals a hypotenuse squared. By using the Pythagorean theorem, we could figure this out to be radical 2. Now, if I take a similar right triangle, okay, and a similar right triangle is a right triangle where the angles are equal. So say those are both 45 degrees. And let's say instead of 1, let's say I double that length. Okay, just pretend this is double the length here. Okay, if I double that leg, in order for this to also be a 45-45 right triangle, these also have to be doubled. Okay, so the ratio of the sides, 1 to 1, is equal to the ratio of those sides, 2 to 2. Okay, 2 over 2 reduces to 1 over 1. Okay, the ratio of the hypotenuse to the leg is the same as the ratio from that hypotenuse to that leg. Radical 2 over 1 equals 2 radical 2 over 2, because here the 2's would cancel. Okay, similarly, if I took any 45-45 right triangle, okay, say this was 8, times that by 8, so in order for that to be isosceles, this would also have to be 8, and this would be 8 radical 2. If I take the ratio of the hypotenuse to the side, 8 radical 2 over 2, and took the ratio of that hypotenuse to that side, 2 radical 2 over 2, I'm sorry, that'd be an 8 down here, wouldn't it? 8 radical 2 over 8 down there. Here the 8's would cancel, here the 2's would cancel, radical 2 equals radical 2. The ratio of the lengths of the sides will always be the same, assuming that these have the same angles. Okay? So if these angles are the same, the ratios of the length side will always be equal. Okay? Let's take another famous right triangle here. The other famous right triangle, say that's 30 degrees and that's 60 degrees. And the reason I pick 30 and 60 right triangles is because I can do those in my head. I don't have to do any calculating. If this is length 1, this would be double that, and this would be radical 3. So what I'm basically trying to get through your heads right now is if I were to draw another right triangle, and I knew this was 30 degrees, and I know this was, pick a number, 5, okay? I know that in order for this to be 30, or I know that since this is 30, the ratios of length and size will always be the same. And since that length was 1 and this was double that, 2, if this length is 5, this length has to be double that number, which would be 10. Okay, and then this has to be 60. Those two angles have to add up to 90, because all three angles add up to 180. And then this was just 1 times radical 3, so this length would have to be 5 times radical 3. The ratio of the lengths of the sides will be equal. 10 over 5 is equal to 2 over 1. 5 radical 3 over 5 is equal to radical 3 over 1. So if this is 30 degrees, the ratio of these sides will always be the same. Okay? So that's the first thing we need to get to understand. Okay? If I drew you another right triangle and I said this was 30 degrees, and say that's 30 degrees, and I just pick a number like 8. What's this have to be? Okay, has to be 16. And what's this length have to be? Has to be 8 radical 3, whatever that is as a decimal, who knows. Okay, and this would have to be 60. The ratios have to be equal. Okay, let's just take a generic right triangle. Okay, generic right triangle, and over here this is the hypotenuse, and we have 2 angles. Let's just pick one, the top one, and we're going to put a little variable there. Okay, that's called a theta sign. It's a circle with a little arc through it. It's called theta. If you start Googling right triangle trigonometry, or just trigonometry in general, you'll see a lot of the variables they use is theta. On the problems we do on the computer, I'll probably have letters like A, B, and C, but because I can't find theta on the Chromebook to type. But theta is a common variable you'll see. It's just a Greek letter. If this is the angle I'm dealing with, okay, the hypotenuse doesn't change. The hypotenuse is always opposite the right angle. Over here, opposite of the angle would be the opposite side. Okay? And then see how your angle is touching the hypotenuse? It's also touching this leg. And the leg that it's touching is called the adjacent leg. Okay? So we have, given this triangle, you have the opposite side, the adjacent side, and the hypotenuse. Okay? Now, there are 6 trigonometric functions, and you can Google these. If you just Google 6 trig functions, you'll find these. Okay, the first one is sine. Okay? It's spelled S-I-N-E. We shorten it S-I-N. Okay, sine of theta equals the length of the opposite side over the length of the hypotenuse. Okay, so we say sine equals opposite over hypotenuse. Cosine of theta. Cosine of theta is the length of the adjacent side over the length of the hypotenuse. And then the last one, you should be somewhat familiar with these from geometry, is tangent of theta. Tangent of theta equals the opposite side over the adjacent side. Okay? And you should probably Google these. They're everywhere on the internet. Those are the ones you should be familiar with. Okay, let me go over here a little bit. The other 3 that you may not be familiar with, we won't use them a whole lot, but I need to introduce you to them. The first one is CSC, that is cosecant. Cosecant of theta is just the length of the hypotenuse divided by the length of the opposite side. Secant of theta, and secant of theta is equal to the length of the hypotenuse divided by the length of the adjacent side. It's just the reciprocal of cosine. Cosecant is the reciprocal of sine. You would think it'd be the other way because S and S and C, but they flipped it around to confuse children, I think. And then the last one is cotangent of theta, and that's just the reciprocal of tangent. So it'd be adjacent over opposite. All right. Pause the video right now. Make sure you write this down, especially these 3. These are the 3 we'll use all the time. These 3 we'll be using on the first few problems, and then just everybody who goes into advanced math should know them, I guess. Pause the video, write those down, and then I'll show you an example of what you're going to do in the first few problems. Okay? Okay. Hopefully you paused the video, like I said, and wrote those down, because we're going to need them. Example 1, and this is how you'll do the first few problems. Okay, you'll be given a right triangle. We'll call it triangle ABC. Angles are capital letters. Opposite of angle A, we'll have side A. Opposite of angle B, we'll have side B. Opposite of angle C, we'll have side C, and those will be lowercase letters. Okay, the side lengths are lowercase letters, the angles are uppercase. Let's say I give you C as 17, and we'll give you B as 8. And let's say we use this angle here. We'll call that angle theta. Okay, or you can call it angle B if you want. Find the 6 trig functions of theta. Okay. Well, the first thing you need to do is find this side. And how do we find that side, boys and girls? Pythagorean theorem. A squared plus B squared equals C squared. That's 289. That's 64. If I take 289 and I subtract 64, I'll get 225. So that gives me A is 15. Okay, hopefully you guys can do that without my help. So the 6 trig functions here, sine of theta. Okay, and I'm not really worried about figuring out what the angle measure is just yet. We'll worry about that later. Sine of theta is the length of the opposite side, 8, divided by the length of the hypotenuse, 17. Now sometimes when you do this, you'll get a radical. If you get a radical, just leave it. Like if this would have been radical 15, just leave radical 15. Don't worry about trying to simplify it or changing it. Cosine of theta. Cosine of theta is the adjacent side. So if this is the angle that we're using, this is the adjacent side. That would be 15 over 17. And then tangent of theta. Tangent of theta would be opposite over adjacent. That would be 8 over 15. Okay, so you're just finding the ratios of the length of the side. So if you have sides of this, the angle would always be the same, and the ratio of these sides would always be that. So whatever theta is, the length of the ratio of the opposite divided by hypotenuse is 8 over 17 always. Okay, the ratio of the adjacent side of the hypotenuse is 15 over 17 always. And just because we're running low on time, let's finish this up. Cosecant of theta would be the reciprocal of that, 17 over 8, the length of the hypotenuse over the length of the opposite side. Secant of theta would be 17 over 15, the reciprocal of cosine. And cotangent of theta would be the reciprocal of tangent, 15 over 8. All right. So all you're doing is you're finding the sides. If this is the angle, that would be the opposite. This would be the adjacent, and opposite of the right angle is always the hypotenuse. Okay. And if you need the old thing to remember it's SOHCAHTOA. Okay, you remember seeing that? Sine is opposite over hypotenuse. Excuse me. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. There will be an example on your Desmos thing too. All right. Good luck.